All right, guys, so again, I'm going to timestamp this video. If we don't need to watch all of it, that's fine. So today I'm going to fill out with you page 40 and 41 in our notebook, and we are going to talk about relations versus functions. So they're kind of similar, but kind of different. So we're going to talk about that, like how they're similar and how they're different. So let's turn the page to 40. And I actually want to start on 40. So like I folded that one in half. And I'm going to write actually the definition for you here. So when it comes to a relation kind of makes sense. It's like a partnership between numbers. So kind of like a relationship in real life. It's a partnership between two people. Okay. So a relation is a collection of points that could be represented in different ways. So represented by either like an ordered pair, so like x comma y. So a relation would be a collection of those. So it could be one of those or two of those or three of those or whatever. Okay, so again, it's a relationship between two things. So it's kind of the relationship between x and y. Now we could also represent it in what's called a mapping diagram. And we're going to talk about all these things more. Diagram, geez. Could be represented in a table or a graph. So like a T-chart table where we do like X on one side and then Y on the other, or a graph where we have an X and Y axis. So table, like X and Y, and then a graph, X and Y. And then the mapping diagram, just really briefly, is like the two things where we draw arrows, which again, we're going to try all these in just a second, so don't stress. Now, a function is really a better relationship. So you might have a relationship with someone, but it's not very functional. Like it's toxic, right? We don't want that. So a function is a better relation because it's one-to-one, meaning one and one. Like we are exclusive with each other. We're not seeing other people on the side, like you got your side chick. Sorry, I'm just saying, but that's kind of how I remember it. A relation is maybe you got that side chick. Function, you don't. You are committed to one other person. So it's one-to-one, which really just means in terms of like mathy stuff. So meaning there is one x for each y. Okay, so there aren't two going on. And again, it can be represented in all the same ways with an ordered pair, a mapping diagram, a table, and a graph. And so we're going to look at all those things now. So to decide if something is just a relation or a function, I always ask the question, because again, we're trying to be a function. A functional relationship is better. So is it a function or not? That's really the question we're asking. Is it a function or not? Got the sniffles, sorry. So again, one way that we can represent a relation or a function is with a table. Okay, so these are all going to be our functional relationships. These are not a functional relationship. So if I were to give you a set of ordered pairs, and we're going to use the same set every time. I wish I would have left a little more room at the top there. That's all right. We'll squeeze it in. So using our fun little curly brackies, maybe we have the points negative 2 comma 2, 0 comma 3, 1 comma negative 1, and 2 comma 4. We'll use those on this side, versus over here we're going to use the points negative 3 comma 2, negative 1 comma 2, negative 1 comma 1, and 2 comma negative 3. Sorry, they're kind of all over the place. Alrighty, so if these are my points, one way that I can represent a function is in a table. So when we make a table, x always goes on the left, y goes on the right, and again, we're just putting them in like alphabetical order. X goes first, y goes second. And so I would list the x value, this first point, and then the y value that goes with it. And we just go through and do that for each one. So the x value here is 0, y value is 3, x value is 1, y value is negative 1, x value is 2, y value is 4. So I can tell from this table that it is a function because each x is paired with one y. And I can tell that really because like as I'm looking at these x's, there are no repeated x's. So no repeated x's. That's what makes that a function. Versus on the other hand, so if I go make a table over here, we got our x and our y. Using these points now, we have the point negative 3 and 2 goes with it. Negative 1 and 2 goes with it. 2 and negative 3 goes with that. And then negative 1 and 1. So as I'm looking through this, I do have repeated x values. So the fact that negative 1 is hanging out with the 2, and on the side, negative 1's hanging out with 1, it's got that side chick, it's not functional. It's not going to be good. Okay, so I can tell that this is not a function because the x value of negative 1 has two different y values. He's got that main chick, he's got that side chick. That's not okay. So really, in simple terms, there is an x value that is repeated. Now notice that it doesn't matter that the y values are repeated. That's okay. So don't worry about it. Another way to represent a function in a relation is with a mapping diagram. So maybe you guys have seen these before. We always kind of do like two little ovals. And then in one side, we put our x values, again, on the left. And then on the other, we put our y values. Now, I always like to put these in numerical order. And I'm not going to be redundant and repeat things. So as I look through my x values here, they're already in numerical order. So negative 2, 0, 1, and 2. Now over here, I'm going to put these in numerical order. It doesn't like super matter. I don't know. It makes sense to me to put them in numerical order. So negative 1, then the 2, then the 3, then the 4. So to show your function, or like who goes with who, like who is relating to who, or like who is in a relationship with somebody, we draw arrows. So negative 2 is in a relationship with 2. 0 is with 3. 1 is with negative 1. And 2 is with 4. So I can tell that this is a functional relationship or a function because, again, each x is paired with one y, right? This x, one y, this x, one y, this x, one y. So kind of in simple terms, there's only one arrow or one line coming out of each x. So one line from each x. Like the one coming out of here, one coming out of here, one coming out of here, one coming out of here. Okay, so same deal over here. We got our x and our y bubbles. And I like to, again, put them in numerical order. And I'm only going to write the number once. Like, I don't need to write it multiple times. So, like, we got -3, -1, and 2. And then over here in numerical order, I got -3, 1, and 2. So if I draw my relation now, like who goes with who, -3 goes with 2. -1 goes with 2. 2 goes with -3. And then -1 goes with 1. So that right there, I can see that -1's having to split his time. Like, that main chick is not getting enough attention. I'm sorry, but this analogy just works too well. Because -1 is going to 2 different numbers, that shows me that it is not a function. It's a relation, but it's not great. So again, I can tell that this is not a function because the x value is paired with 2 different y values, right? This x value is paired with this guy and that guy. Not good. And again, in more simple terms, there are 2 arrows or 2 lines coming out of 1x. So because I got 2 coming out here, not good. Not a function. That's just a relation. Alrighty, so the last way that we can represent this is with a graph. So like on a graph, we have our x and y axis. X is horizontal, y is vertical. Okay, so we're just going to plot each of these points, and I can tell from any one of these things who goes with who. So -2 goes with 2, so I go -2 and then 2 and plot my point. 0 goes with 3, so I go 0 and then 3 and plot my point. 1 goes with -1, so I go 1 and then -1. And then 2 goes with 4. Man, that wasn't a great arrow to 4. Geez, what was I? 2 goes with 4. So I go over 2 and then up 1, 2, 3, 4. Boop. Now, the way that we tell on a graph if something is a function or not is we use what's called a vertical line test. So the vertical line test is I basically just take a vertical line, a line going up and down, and if I sort of sweep it through at any spot on this grid, it only touches 1 point at a time. So this is fine, this is fine, this is fine, this is fine. It never touches, like the vertical line never touches 2 points. So this passes the vertical line test. Which again, anywhere you draw a vertical line, it only touches once. Like your graph only touches once. Now my graph here is just ordered pairs, but it only touches once. Now on this one is not a function, so I already know it's going to not be a function, but when we plot these points, I'll show you how it fails the vertical line test. So if we plot these up, like the -3 is with the 2, so we'll go -3, (2). -1 is with the 1, so -1, 1. It's also with the 2, so right there. And then 2 is with the -3 rather. So we go over 2 and then down 3. So again, right here, if I sweep that vertical line through, like it fails. Because if I were to draw this vertical line, 2 points are on it. So it touched twice. It's not good. Okay, so this fails the vertical line test. Vertical line test, VLT. Touches twice, 2 times, or more. I mean, if it touched more, that'd be even worse, but if it touches twice, that's enough. Alrighty, so over here, this is what I'm going to have you guys turn in for your points on the notes here. We're going to decide if these things are functions or not. So I'm going to put this one with that one. So we're going to want to look at this graph and decide, is it a function or is it not a function? And then why? Like, how do you know? Did you use like a table, a mapping, or a look at the graph and do the vertical line test? This should really have our little ovals around it. And we're going to use this one here. So same question, is this guy a function or not? And how do you know? So again, and then this one here we'll use with the table. So looking at this table, is it a function or not? And how do you know? So we'll check that and we'll talk about it when I see you next. Okay, bye.